back to business with our Unit 2 review and back to business with our poorly done periodic table. Yeah, I just sat down, set the other video up to upload, and here I am again. It's the next day for you, though. So, with this periodic table, I didn't change much. What's important now are the group numbers up at the top. I left my pink metalloid scribble there because groups 13 through, I guess, 17 really don't have much going on in terms of group names. There's some you could give them. We could call them like the family, the carbon family, the nitrogen family. You'll see that, but we don't use those in this class. Because you can call anything the family, because remember, if you're talking top to bottom, I call them groups, but you'll see them as columns and families also. And I call them rows going across, but you also hear them called periods. We'll talk about these two series at the bottom, which are sections of rows. So, let's check this out. Group 1, they're metals. They're alkali metals. Alkali metals are soft, they're reactive, and you can cut them with a knife. They are still metals, though, but remember, who's the odd one out? My dog says hydrogen. Hydrogen is the odd one out. It's not really a metal. It's not over there. So, you've got the stray, but the rest of that group are alkali metals. If you're marking a periodic table and you have colored pencils or crayons or pens, go through now and color your group 1, not hydrogen, as your alkali metals. You'll need, I believe, 7 colors if you're doing this the whole way through. So, for group 2, the alkaline earth metals are the whole column, and the metals here are less soft and less reactive than the other metals in group 1. We're getting more toward normal metal properties, but they are similar in that they're not your standard metal. They're not as solid as iron or zinc. They can't be found alone as much as iron or zinc. For groups 3 through 12, you have transition metals, and these to me are just metals. Things like gold, silver, copper, they're normal metals. They're what you think of. Most are silver. All of them are pretty shiny. They're just the real deal. So pick your favorite color for this, 3 through 12. 13 through 16 are busy being a mixture of metals, nonmetals, and metalloids. So we just let them be. If you look on the periodic table with the links I gave you here, it just sort of labels them as metals below and nonmetals above, and okay, cool. We don't classify them because they don't match. Group 17 are your halogens. These are mostly gases, except bromine can be a liquid and iodine can even be a solid. But it's a soft solid, not hard like a metal. They are really reactive. They love group 1. That's how you get sodium chloride. The word halogen means salt former, like the Cl with the Na to make table salt. Group 18 are your noble gases. Noble means not kingly in this sense, but unreactive. For the most part, group 18 doesn't react. And I tell you that, and then in packet 5, I think, we start drawing xenon compounds and I get angry. Every time. So those are your groups that you'll need to know. Again, mark your periodic table up, you'll be able to use it. At the bottom, we have 2 series. If you look on your periodic table, the top one comes out right after the element lanthanum, La. So that's going to be my lanthanide series. And my bottom one comes out right after actinium, Ac. So we call them the lanthanides and the actinides. The lanthanides are called rare earth. They're not really that common. They're useful for some technology applications. I don't think I own any of them. Actinides are cool. Anything past uranium is radioactive and decays. A lot of them start to get into your man-made elements down there. So those are pretty cool. And that is your division of the periodic table into its groups and these 2 series. They're like bonus content of the series. So there you go. Masses. You guys did not like or did not remember the units on these masses well, because they all come from the periodic table and the only difference literally are the units. So if I look at these, I have them written down and I'll put them, I'm actually just going to, I think I'm going to stick them in the transition metals. I'll stick them in groups 3 through 12 and show you what I'm doing. Maybe we'll pick a transition metal if I can think of one. I think the mass of titanium, if not, we're going to make it up. Something like that. Well, there's a mass for an element, one way or another. 47.88. So, when I look at this mass, I wrote down my decimal from the periodic table. That's where I start for all of these masses. The difference among three of them is just the units. Relative mass is a comparison, so right now this is a relative mass. No units are given because I compare. Relative mass, no units. Atomic mass. We write it in the atomic mass unit. It's the mass of one atom. It's tiny. Tiny, tiny. AMU. And the mass we've been using for molar mass is grams. You might see a molar mass, especially when we do calculations, written as grams per mole. Okay. Formula mass, too, you can do as grams per mole. If you just write grams, we know that it's in 1 mole. But when we start canceling units, grams per mole gets used sometimes. I just go grams on this one, and since you're going to have multiple choice, I will give you grams. So that's a molar mass. So far, all I did with relative, atomic, and molar masses was change the units, but now here's the mass number. Putting number in this is a nice clue that I got to do something different. Mass number is the periodic table mass, the decimal from the periodic table, rounded to the nearest whole number. 47.88 rounds up, so 48. We're going to need this packet for counting protons, neutrons, and electrons. I got some more formula mass stuff to do, and I guess I do have to sacrifice my periodic table, my lovely drawing, for this one. At this point, I just hope the video records. So I've got formula mass for you next. You're going to need a periodic table with masses on it, or a list of the masses to do this. When we calculate a formula mass, all we do is add things up. I believe that the two you're doing in your packet, and I'm going over with you, are the formula masses of ethane and of calcium hydroxide. Ethane, C2H6. I got to give you those. I'm not going to have you figure out the mass of something and then not give you a formula. So, here we go. Remember, my subscripts tell me how many of each there are, so this is telling me I have 2 carbons and 6 hydrogens. That means to get my mass of ethane, I need to do 2 times the mass of carbon from the periodic table and 6 times the mass of hydrogen from the periodic table. Carbon, I looked, it's 12.011 grams. That's 24.022 grams total. Hydrogen is 6 times 1.0079 grams. So, enter that into my calculator. 6 times 1.0079 gives me 6.0474 grams. Since formula mass is a total of all of the elements in a compound, we've got this coming up. And when I add those two numbers together, 24.022 added to the 6.0474, I get 30.0694 grams. Now, significant digits-wise, this is a nightmare because everyone's periodic table keeps a different number of significant digits. Write down what you have. Like I said, I've been checking the quizzes. This will be multiple choice, so pick the one closest, and you're good to go. Now, if you want to do one of these on your own, you can pause this here. I'm going to put up the calculation for calcium hydroxide also. Remember, the 2 outside the parentheses goes to both oxygen and hydrogen. So if you want to stop and do that on your own, go ahead. If not, I'm going to put it up in place of ethane now, because you can always go back if you need to. Calcium hydroxide, CaOH, 2, 1 calcium. This 2 goes to both of those because of the parentheses. So 1 calcium is going to give me 40.08 grams right from the periodic table. I don't need to do anything else because this 2 doesn't go to the calcium because calcium's not in the parentheses. 2 oxygens is 2 times periodic table mass, 15.999 grams for 31.998 grams of oxygen. 2 hydrogens, 2 times 1.0079 grams for 2.0158 grams of hydrogen. And I'm just going to add those up. 40.08 plus 31.998 plus 2.0158 equals, I got me 74.0938 grams. That's my formula mass of calcium hydroxide. And that's where we're stopping today. I forgot to tell you last video that at the end of this packet are practice questions. It really wasn't that tough for the first one, just going through and looking at your alkali metals and all of, or the metals, non-metals, metalloids the first time. Going through and getting some information about that. There are a few practice problems for you to try on this stuff, and I'll be giving you the answers next time, or maybe at the end of the review when you're all done. You'll be provided with the answers. Keep working on these. There is a big review that's due really close to the time of the final. That's worth, I think, 30 points when the final is worth 50. So a lot of your grade on the final is actually the work you're able to do on your own, with your notes, with everything. So keep up the good work. We're going to work more with masses next time in calculating percent composition. And we'll continue looking toward the end of the packet, comparing empirical and molecular formulas, and counting protons, neutrons, and electrons. So this is day 2 of your review for Unit 2. More fun yet to come. Have a great day.